Type-TC cable can be used from the service panel to a sub-panel in a garage. There is no inherent problem with this application, provided that several crucial factors are addressed. The most important consideration is proper sizing for the amperage of the intended circuit. The ampacity of the conductors within the TC cable must be sufficient to handle the load without exceeding the cable's temperature rating. Refer to the National Electrical Code, specifically Table 310.15b16, or the appropriate table in your local electrical code, to determine the allowable ampacity of conductors based on their size, insulation type, and ambient temperature. Remember to account for any dirtying factors that may apply, such as the number of current carrying conductors in a raceway or cable, or high ambient temperatures. Type-TC cable, which stands for tray cable, is a multi-conductor control or power cable designed for use in cable trays, raceways, or direct burial applications. It is constructed with insulated conductors, often with an overall jacket for protection against physical damage and environmental factors. While commonly employed in industrial settings and for underground installations, its use is not restricted to those environments. It is permissible for indoor installations, including residential applications like feeding a sub-panel in a garage, assuming it meets all relevant code requirements. The comparison to SER cable, which stands for Service Entrance Cable, is relevant because SER is a common choice for feeding sub-panels. SER cable is typically less expensive than Type-TC cable. However, Type-TC cable offers some advantages in certain situations. It is generally more robust and resistant to physical damage and environmental factors, making it a suitable choice where these considerations are paramount. When making the decision between Type-TC and SER cable, consider these factors: firstly, the cost of each cable type; secondly, the required ampacity of the circuit; thirdly, the environmental conditions in the installation location; fourthly, any specific requirements of the local electrical code. The high cost of Type-TC cable may be justified in situations where its superior durability and resistance to damage are beneficial. To elaborate on the NEC requirements and best practices for this type of installation, consider the following. Firstly, overcurrent protection. Both the main service panel and the sub-panel must have appropriate overcurrent protection devices, such as circuit breakers or fuses, to protect the conductors from overload and short-circuit conditions. The size of the overcurrent protection device should be based on the ampacity of the conductors, as determined by the NEC. Secondly, grounding. Proper grounding is essential for electrical safety. The sub-panel must be properly grounded back to the main service panel. This typically involves running a grounding conductor, such as a green insulated wire or a bare copper wire, along with the circuit conductors. The size of the grounding conductor must be in accordance with the NEC Table 250.122, which specifies the minimum size of equipment grounding conductors based on the size of the overcurrent protection device. Thirdly, bonding. All metal enclosures, such as the sub-panel enclosure and any metallic raceways or cable trays, must be properly bonded to the grounding system. This ensures that all metal parts are at the same electrical potential, minimizing the risk of electric shock. Bonding can be achieved by using bonding jumpers or bonding screws to connect the metal enclosures to the grounding conductor. Fourthly, cable support and protection. The TC cable must be properly supported and protected throughout its run. This may involve using cable ties, cable clamps, or other approved methods to secure the cable to the building structure. The cable must also be protected from physical damage, such as being run through conduit or raceway in areas where it is exposed to impact or abrasion. Fifthly, working space and clearances. Ensure that there is adequate working space around the sub-panel for safe access and maintenance. The NEC specifies minimum working space requirements in Article 110.26, which include minimum clearances in front of electrical equipment, as well as minimum heights and widths for access pathways. Sixthly, labeling and identification. All electrical panels and circuits must be properly labeled and identified. This includes labeling the sub-panel with its voltage, amperage rating, and the source of its power supply. Each circuit breaker or fuse in the sub-panel must also be labeled to indicate the loads that it serves. Seventhly, local codes and permits. Before starting any electrical work, check with the local building department to determine if any permits are required. Many jurisdictions require permits for electrical installations, and it is important to comply with all applicable codes and regulations. Eighthly, professional installation. If unsure about any aspect of the electrical installation, consult with a qualified electrician. Electrical work can be dangerous, and it is important to have it done by someone who is knowledgeable and experienced. Furthermore, consider the specific installation details and how they might affect the choice between Type TC and SCR cable. For instance, if the cable run will be exposed to direct sunlight, Type TC cable with a sunlight-resistant jacket may be a better choice than SCR cable, which may degrade over time when exposed to ultraviolet radiation. Similarly, if the cable will be installed in a wet or damp location, Type TC cable with a moisture-resistant jacket may be preferable. In addition to the NEC requirements, it is also important to follow any manufacturer's instructions for the installation of the Type TC cable and the sub-panel. The manufacturer's instructions may provide specific guidance on cable support, termination methods, and other important considerations. Here are some additional details to consider regarding the use of Type TC cable. Firstly, conductor types. Type TC cable is available with various conductor types, such as copper or aluminum. Copper conductors are generally preferred for their higher conductivity and lower resistance, but aluminum conductors may be used in some applications to reduce cost. Secondly, insulation types. Type TC cable is also available with various insulation types, such as PVC, XLPE, or EPR. The insulation type should be selected based on the operating temperature and environmental conditions. Thirdly, shielding. Some Type TC cables are shielded to reduce electromagnetic interference. Shielded cables may be required in sensitive electronic environments. Fourthly, direct burial. Some Type TC cables are approved for direct burial, meaning they can be buried directly in the ground without the need for conduit. However, it is important to follow the manufacturer's instructions for direct burial installations, including proper burial depth and backfill materials. Fifthly, cable trays. Type TC cable is commonly used in cable tray systems. Cable trays provide a convenient and organized way to support and route cables in industrial and commercial buildings. Sixthly, connectors and terminations. Use appropriate connectors and terminations for the Type TC cable. The connectors and terminations should be compatible with the conductor material and insulation type, and they should be properly installed to ensure a reliable electrical connection. Seventhly, inspection and testing. After the electrical installation is complete, it is important to have it inspected and tested by a qualified electrician or electrical inspector. The inspection and testing should verify that the installation complies with all applicable codes and regulations and that it is safe and functional. Therefore, using Type TC cable to feed a sub-panel is acceptable provided all the code requirements are met, and it may offer some advantages over SCR cable in certain installations. The selection depends on factors such as cost, environment, and local regulations.